Welcome, fellow recovering traditionalists, to episode 191. Don't miss these powerful Math PD sessions from the virtual Math Summit. Welcome to Build Math Minds, the podcast, where fidelity to your students is greater than fidelity to your textbook. I'm your host, Christina Tonnevold, the recovering traditionalist and BuildMathMinds.com founder, where my mission is to change the way we teach elementary math to our kiddos. So, are you ready to start building math minds and not just creating calculators? Let's get started. The day I'm releasing this episode is March 2nd. And tomorrow, March 3rd, is the last day to watch the replays from the 2025 Virtual Math Summit for free. And if you haven't joined us yet, you can still register at virtualmathsummit.com, but you've only got today and tomorrow to watch these sessions, so hurry it up. What have you been waiting for? I've been doing all these videos to get you pumped for it, so if you haven't joined yet, come on. But this year, just to pique your interest a little bit more before they go away, we did 6 live sessions during the summit, so I didn't have clips from those presenters or those presentations even to share with you. Now that those sessions have actually happened, I can share a clip from each of them. Peter Liljedahl and Maegan Giroux did our opening keynote about building thinking classrooms, and they shared some of the tasks from their recently released book, Mathematics Tasks for the Thinking Classroom. Here's one of my favorite parts of their session.
And there's also the non example. And this one is really, really great because I think that sometimes we want to give people a way to solve the problem, but the best way is to tell them how to not solve the problem.
Yeah.
So the classic example is
tax collector, right? Like if you start with 12, it goes badly very quickly. But that's okay. That's where they want to start. That's where we're going to start because this helps them understand what the task is about without telling them how to do the task.
Exactly. And that is the same with the carnival conundrum. We have Thane losing, right? He loses, and then you know how not to solve the task. But also, surprisingly, you do know how to solve it from there without us telling you.
Yeah.
And
this is one of the things that we actually found in our research too, is that teachers' examples are too good. And when teachers' examples are too good, the kids just copy it. We need to create as often as we can non-examples. Bad examples. Be worse at your examples.
Be really, really bad at your examples. Now, this is my favorite thing because I see teachers do this and myself do this all the time is we like to tell kids things just in case. And it's like right before you are about to send them off, you will have this like I'm itching to tell them everything they need to know about task 25. And so you go, and then you say like this, and you're like, let me tell you something. Let me tell you something. And you need to like tell them everything right before they go. Don't.
And it's Julie Dixon is the one who coined these terms of just in case versus just in time. And what we tend to do as teachers is we want to, just in case you're going to see one with negative numbers, let me do that one for you. And just in case you see one with a fraction, let me show you one of those. And just in case, and just in case, and just in case. And now we're now 17 and a half minutes into the lesson, and the kids haven't even gotten out to play yet, right? Like we have to stop doing the just in case, and we have to lean more into just in time, which we'll talk about in a little bit.
Exactly. So like let them go, give them just enough to do the first task.
Yeah.
That's all they need. We can figure out the rest later.
Pam Harris also has a new book coming out in, I think, just about a week about avoiding the trap of the algorithms. She is always a favorite of the summit, and yet again, she did not disappoint this year.
Sweet. So I can use what I know to solve problems. Hey, don't tell Christina, but I came a little unprepared for today's presentation. So I don't actually have, will you notice with me that if you look at what we've done so far, I kind of gave you a helper. Look at my shared screen. I gave you a helper to do that problem. And I gave you a helper to do that problem. And I gave you a helper that you could use to do that problem. And I gave you a helper that you could choose to use to do that problem. And I gave you a helper you could choose to use to do that problem. What if for the next problem, I don't give you a helper? What if I came unprepared? If you guys will help me create the helper, Next time I do this presentation, I'll look totally slick. So what if I were to give you a problem like, I don't know, something like 5,468 plus 2,997. I'm going to move that just a little bit to give us some space. What if, what is the problem that goes right here? What would the helper problem be? Don't look in the chat if you're still thinking. Everybody think. If we were in a class right now, I would be having everybody pause, give me a private signal. I'd get everybody a chance to think. What could be a problem if you were going to follow the pattern that we've been using? What could be a problem you could use to help you solve this one? A lot of people are putting in the chat. Could you think about 5,468 plus 3,000? Y'all, what is to make this one, 5,468 plus, whoa, that huge jump of 3,000. A lot of you are saying that that's 8,468. So if that's 8,468, what would be adding just a little bit less? In fact, how much less? Just 3 less? If we just backed up that 3, would that jump then instead be 2,997? Cool. And you guys are saying that that is landing on 8,460. What's 3 less? 5. Is it? Anybody want to check that? Right now, do you get a desire to like line those numbers up and check it? I'm okay if you do that. I might suggest to you that you could just put it in a calculator. Like if you're going to do something sort of mindless that you're just kind of mimicking and you're doing the thing, you could do something equally mindless by typing it in a calculator if you feel the desire to check. But how many of you, take a deep breath, how many of you are really clear in this minute that because you know what 5,468 and 3,000 is, that it's got to just be 3 less? And you're actually like, I don't really need to check that. Like, it's got to be just 3 less than that. It's got to be 8,465. That's kind of interesting that when you reason through using relationships, you're pretty darn confident in that answer.
Shannon Olson was a woman after my own heart. Her session was about effectively using and connecting math representations and using them as tools to observe and assess student thinking, identifying misconceptions, and then guiding instruction. Listen in to a part of her session.
And now we're going to unpack how we define different types of representations now that we've engaged in a task to actually work with those representations. All right, this visual comes from NCTM. It's also been published in so many books about discourse and representations and effective teaching practices. But it talks about we have these 5 types of representations and that we can connect between all of the different ways and continue to make sense of math through these representations. I like to use more like student-friendly words. I know that when I first heard of these representations, I was all on board about physical, visual, and symbolic. I feel like so often we hear things like concrete, representational, abstract, and we're just really comfortable with knowing we use objects, pictures, and equations. And it took me a little bit to understand, what do they mean by verbal? What do they mean by contextual? And so I have started to think of contextual actually as the one that leads our work. I used to think of contextual as this thing we add on a context, and now I've started to think actually context is what helps us build objects and create drawings and equations. And not that we always have to start with context, but I really think of contextual representations as just the stories we tell, whether that be a word problem or a math task or just any context of something that we're working with. Physical is objects, and that can be commercial manipulatives or just real life physical objects that we work with. Visuals, any type of drawing or diagram or picture that we use to represent our thinking in math. Symbolic is anything with numbers and equations. So it can be literally just writing the number 5, the number 12, or it can be writing 5 plus 7, or it can be having a multiplication equation with parentheses and all kinds of other things we could work through. Verbal is really just using our words to describe our thinking. And it can be when we provide sentence frames to students or just saying, this is how I see the dots on the page.
One of my favorite tools for elementary kids to use are 10 frames. Kim Rimbey's session showed us how this tool can be used throughout the grades. Here's a great part of her session.
Oh, yes, the counting collections idea. I just saw someone ask about this. I totally connect this with counting collections. This is one way kids can represent their thinking when they're working with their counting collections, right? So here's what you should have. Leora, is that how you say your name? She wants to see decimals. Hold on, we're heading there. So here we go, 635 million. When we touch that comma, we're going to say million. 92,843. Again, I can't say it enough. You have to make sure that the kids understand that nesting nature of place value. Over here in the millions period, these dots have a magnitude. Each one has a magnitude of 1 million. Each line is a group of 10 million. Each circle is a group of 100 million. The only thing we're counting the whole time are just the little orange tiles, right? It's how many of these are grouped and nested and nested and nested and nested. So the yellow lids, they're just covers. The blue lids are just covers. Covering with a white piece of paper, it's just a cover. We're talking about how many are grouped together. That is something that has eluded most of our conversations. We know that intuitively, but the way we talk about this with students matters. And it's really hard to have a tool that really helps us have that conversation unless we've explicitly thought it through. So that's why I have you participating today, is I want you to just be really thinking this through. How are you going to explain this to your 5-year-olds? How are you going to explain this to your 5th graders and everything in between? So a couple of notes as we're looking at this before we shift into decimals is that first off, I'm hoping that you're seeing what I mean by what happens in the ones place happens in every place, right? We have this structure, and I'm using the 10 frame structure in every place for the kids to see that in every place, although the magnitude is changing, the structure has a common theme. And now we've just added another corollary or a corollary to this. What happens in the units period with ones, tens, and hundreds is replicated in every period, right? So the millions period still has a ones, tens, and hundreds, but the magnitude has changed. So that's where I'm going with this. So you guys have been doing such a great job of participating in the chat box as we go. I just want to give everyone a chance to reflect. So far, what are you noticing about the patterns as we go from small numbers to large numbers?
Latrenda Knighten is the president of the National Council of Teachers of Mathematics, and I've been a member of NCTM since I became a teacher back in 2000. Well, actually, I think I became a member during the spring of my first year of teaching, so it was technically 2001. I highly recommend educators join this organization. I'll link up NCTM in the show notes, but let me get back on topic here. Here's a clip from Latrenda's session about using instructional routines to build students' understanding of math content and language.
So let's go back to the activity that we did from Is to Arrive. This is one where I chose to incorporate children's literature. One thing that we don't need to, that we should make sure we don't discount, is those opportunities to bring multiple resources in to support our students with their mathematical learning. We know that using children's literature is a non-threatening strategy. A lot of children will gravitate to using literature, even like some of the books I have pictured here are books for older students. They're chapter books, but they're talking about mathematics. They're exploring those concepts. And so it's a great way for some students who need just the extra little push to feel more comfortable to talk about their thoughts, their ideas, or their feelings of mathematics, is to use those as a context. There are many benefits from using children's literature, but there's so many opportunities for us to provide our students with problem posing content, problem posing concepts and opportunities by using literature. We are so fortunate right now that there's so many wonderful literature books that authentically incorporate mathematics, that there's just so many to choose from. Sometimes I feel as if I'm going broke because every time I see a new book release, I'm thinking, how can I use this? And I feel as if I have to have it. I have to have this book because I may be invited to go to someone's classroom to use this. So take advantage of those things. Encourage the librarians on your campuses to make sure they're purchasing those books. One of the things I love about using the literature is because, remember, it doesn't have to be fictional. So you really have an opportunity to bring in historical, cultural context, as well as practical applications of mathematics. So it really helps enrich that experience for all students and enhance that learning environment. But one of the best ways I found for teachers to incorporate discourse in the classroom on a regular basis is through the use of routines. And so adding it up reminds us that the point of classroom discourse is to develop student understanding of those mathematical ideas. And so these are opportunities for us to emphasize a model, reasoning, and problem solving, but at the same time, we can enhance our students' disposition towards mathematics. That means if I'm having an opportunity to talk about what I'm doing, I'm having an opportunity to listen to my peers and learn other ways of doing this in mathematics, I am growing my repertoire of this concept or this content, but also students are feeling more comfortable with mathematics because they are getting to talk about it. They're getting to reason. They're getting to problem solve. They're having the opportunities to ask those questions. So in order for this to be meaningful and productive, we have to plan for it. It's not just going to happen. Now, students are going to have those discussions, productive or unproductive. But as adults who are in control of the room, we need to plan those opportunities so that we provide students with the necessary tools and resources to have those productive discussions.
And now our final live session was from Ann Elise Record. I love using word problems to connect math concepts to a context for students, and I love using visuals in math. Ann Elise combined both of these in her session.
Now we get a whole flood of the answers happening in the chat bar. I'm seeing both blue and green. Seeing both blue and green. Now, I'll tell you, both are not correct. Only one of them matches the way this story is written. And what I want to ask you to do is reread the top first sentence. There are 2 more ducks than frogs. So what does there have to be more of? 2 more ducks than frogs, right? That means there has to be ducks. Ducks is the higher one. So it can't be that frogs are 7 of them. So why is this, right? So this one on the right-hand side, this story structure, there are 2 more ducks than frogs. So I know, and these numbers are tiny. This is what I'm saying. Give yourself grace. There's zero judgment, right? That these are tiny little numbers, but this is the power of this work and the research. So there are, the relationship is there's 2 more ducks than frogs, and there's more ducks. And we know there are 5 ducks. So this having the 5 ducks, the relationship is there must be 3 frogs. The relationship is that 2 more, that additive comparison, but I made this a tougher problem type because I used the word more, but the smaller amount was the unknown. So this is what I'm talking about. This is the power of this. And this is how the structure, the visualization of this will help you build your confidence. And then we can facilitate that confidence with our students. And the more we do this at the K2 level with the problem types involving adding and subtracting, the more we can continue it all the way through their journey as we add on multi-step. The numbers get larger, we get decimals and fractions we're adding and subtracting, and we also add on multiplication and division. So why is it then that so many people, teachers that I meet and the students, is the choice of that blue side? What is the gut reaction of it must be the blue one? Because we've learned that keywords, right? The word more means add. So I pluck the numbers. Graham Fletcher calls them pluckers. The kids pluck the 5 and the 7. They add the 5 and the 7. 5 and 2 make a 7. That must be it. The answer is right there. I must be right, right? But that is not the case. This is why we can't be doing keywords. We cannot be using things like cubes or any other ways you have for problem solving that involve underlining a key word that would somehow tell us what operation we want the students to use. That is not a part of this journey. It's about finding out the structure. And once I understand the structure, I can choose the way I'm going to calculate my answer for you. We'll get into that for sure.
So again, if you'd like to watch these sessions, you really only have until tomorrow, March 3rd. I'm telling you, that's the deadline to watch it for free. If you want longer than that to watch them, you can always become a member of the Build Math Minds PD site, because our members have access to not only this year's sessions, but all 9 years of virtual math summits for as long as they are members. You can join at buildmathminds.com/BMM. And after saying that, now I'm like super excited for next year's virtual math summit, because next year will be 10 years. 10 years of doing virtual math summits. So we've got to do something big and special for next year, that's for sure. All right. Until next week, my fellow recovering traditionalists, keep letting your students explore math, keep questioning, and most importantly, keep building math minds.